Okay, so we are now starting with chapter 13, and we actually are going to be jumping into 13.2. 13.1 deals with a lot of graphing from different points of view, so we're not going to do that since number one, we're not in class and talk about that. So what we're going to do here is, like I said, chapter 12 dealt with a point moving in space. Well, chapter 13 deals with the point as a vector. Okay, so basically we're going to be looking for, we're going to be finding velocity, acceleration, etc. There's other things that we'll be finding with that of a vector. Now, don't panic, it doesn't really change too much, but let me go through an example of what I mean by instead of, in chapter 12 versus chapter 13, how that is working. So if I graphed out a particle that's moving, so let's say here is my x-axis, my y, and my z, and let's kind of go in the negative realm here on both for a little bit. Okay, so let's say my particle is over here and it travels, so it goes, let's say it goes over the y-axis, and then it comes, let's say, under the x-axis, and it comes up over the top of the y, and then let's say back under the y. So it's moving this direction. So in chapter 12, we were talking about this particle moving and this point being on that line as it moved around. Well, what we can do is, instead of thinking of it as a point, so instead of saying, let's say, x comma y comma z as a point, we can think of it as a vector x, y, and z. So what we can do is track it from a single location. So let's say at 0, 0, 0, we're going to track it as it moves from that single location. And one of the things we can do with that then is we can kind of track in terms of that curvature or the curve as it turns around. So as between, let's say, this vector here and this vector here, how much of a curve, use a different color here, how much a curve it partakes in all this by using those two vectors. But we're going to do different things with this in terms of, like I said, velocity and acceleration and so on. So one thing I want to make a note here is a particle can transverse a curve, and there's keyword curve, as a function of time from a single point. And that's what I was talking about right up here, like so. And that's where we get this, chapter 13 deals with. It's called a vector value function. And that's what we're going to be talking about here. Okay? All right, so let's take a little bit more explaining here. So, therefore, okay, we're going to taking a parametric equation, which is what we did in chapter 12, and writing it as a vector function. Okay. So if we have, let's say my x component here has a function f of t, my y component is g of t, and my z is h of t, and we have that we've been working with here, say rt. My equation is x in terms of my I hat, my y is my j hat, and z is my k hat. Then my vector value function is basically this. It's now an r vector of rt, and we put this as a function of t for my I hat. Plus my g of t for my j hat, and my h of t for my k hat, or basically which implies my vector of f of t, my g of t, and my h of t. Okay. So to conclude on this, so my conclusion is the terminal points of the vector creates or traces, refer to it as either way here, traces a curve. And that's the key word where we are starting to talk about curvature in 3D. And sometimes too you might see it written like this, a region R of 3. That's like, let me rewrite that. That's an R. Region of 3, or region of 3 means 3-dimensional. Now you also can have 2-dimensional. You can do it also there for curvature, but it's kind of the start of understanding and wrapping your head around curvature of an object. This is like curvature of magnetic fields, other objects that move at a certain turns and twists and things like that. So you'll be hearing a lot more about curvature as we progress here, especially once you get into physics. They'll talk about curvature, magnetic fields, electricity. They'll talk about curvature. So this kind of give you a kind of heads up in terms of where we might be going with this. All right, I'm going to stop there. So what we're going to be getting into here is then kind of the basics of how to do this. Now, you'll find out saying this is nothing different than what you've been doing in the past. It builds off Calc 1, limits, limit derivatives, and all that. Product rule, quotient rule, all that stuff follows along. So it's actually is pretty simple. But I'm going to do the next video of how to do all that stuff.